So, fourth chapter of your paper number 1 is operational amplifier as a signal conditioner. So, in this chapter, we have studied what is function of signal conditioner in instrumentation system. The functioning of signal conditioner in instrumentation system is that uh, the signal is converted into desired form to drive the output stage of the instrumentation system, and the circuit used for this is called as signal conditioner. Okay, so signal conditioner makes the signal desirable. Okay, so this chapter, it consists of these points: concept of operational amplifier, its block diagram, definition of basic parameters, IC 741 LM324, concept of virtual ground, opamp as inverting non-inverting amplifier, unity gain follower, adder, subtractor, current to voltage, voltage to current converter, voltage to frequency converter, comparator, and problems based on these applications. So that is what we are going to study in this chapter. Okay. Now, if you see this, what you can observe is the symbolic representation of the operational amplifier. Okay. So, as we have already discussed, amplifier is a circuit which increases the strength of the signal, and operational amplifier is a special type of amplifier which was earlier used for performing analog computations, basically mathematical operations. Analog mathematical operations were possible with help of this operational amplifier, and therefore this amplifier was called as operational because it was used to uh, compute the mathematical expressions, okay, and mathematical operations. So this is how the operational amplifier has come into the field. Okay. So basically, this is a very high gain, directly coupled differential amplifier. Okay. So it has very high gain, voltage gain particularly. Voltage gain means output voltage divided by input voltage. The amount by which it increases the strength of the signal is called as gain. Okay. So such a gain is very high in case of operational amplifier. It is directly coupled. That means suppose if there are two stages of amplifier, then they are coupled with each other, that is connected with each other without any components. Simple wire is used to connect the two stages. Such type of amplifier is called as direct coupled amplifier. So this operational amplifier is direct coupled amplifier, and it is also differential amplifier. Differential amplifier means it has two inputs and its output is proportional to difference between the signals which are present at the two inputs of the amplifier. Okay, so basically it is used to amplify the difference between the signal, and hence it is called as differential amplifier. So our operational amplifier is the amplifier which is available in the integrated circuit form, and it is very high gain amplifier, direct coupled amplifier, and differential amplifier. Okay, so most of the time it is used along with the external feedback components. Okay, so mostly it is used in closed loop type of mode of operation. Okay, so in such mode feedback is present from output to input. So in feedback configuration, mostly operational amplifier is used, but in some applications it is also used in open loop configuration. Okay, and this operational amplifier is a basic building block of analog circuits. Okay, so basic building block means to construct any circuit you can use operational amplifier. That is what is the meaning of this. For example, suppose if you consider to construct a wall, then what is its basic building block? The basic building block of the wall is brick, isn't it? With help of brick we are going to construct a complete wall. Okay, so the wall brick is the basic building block. Like that, any analog electronic circuit can be built with help of operational amplifier, and it is called as uh, analog building block, basic analog building block. Okay, so This is what is speciality of your operational amplifier. And this operational amplifier, as you can see, can be used as inverting amplifier, non-inverting amplifier, voltage follower, adder, subtractor, integrator, differentiator, logarithm amplifier. It is used to solve differential equations. Many more applications are there. Okay, only some of these applications we are going to study in this chapter, because our intention is to study operational amplifier as a signal conditioner, how it works as a signal conditioner. So therefore we are going to study current to voltage, voltage to current, voltage to frequency, all frequency to voltage, all these type of converters with help of operational amplifier. Now if you observe the symbolic representation of operational amplifier, then you can observe here it is drawn in the form of triangle, which has two inputs and one output, and external power supply is applied over here. One input terminal, which is shown by negative sign, is called as inverting input. The another input terminal, which is shown by positive sign, is non-inverting input. Okay, it has single output, and in order to make it work, you have to apply external power supply, and this external power supply to be applied to the operational amplifier is bipolar in nature. That means suppose it requires 15 volt power supply, then your power supply must be bipolar, that is plus minus 15 volt, plus minus 12 volt, plus minus 10 volt, plus minus 9 volt, like that. So bipolar power supply is used to power the operational amplifier. So this is all about its symbolic representation. Now, if you come to this figure, what you can observe, IC 741, basically two types of ICs have been given in your syllabus. One is IC 741 and LM 324. So both of these are operational amplifier ICs. Now, if you see IC 741 here, you can observe this is 8 pin IC. This is 8 pin IC, and 8th pin is no connection. NC means no connection. Okay. So pin number 1 and pin number 5, they are used for offset null. Meaning of offset null is that you are going to adjust certain things before carrying out the experiment, and for that purpose you have to connect a potentiometer between pin number 1 and 5. Okay, and its variable terminal, or it is applied to your power supply, and a certain amount of voltage is applied in series with this operational amplifier to nullify certain effects of the operational amplifier, which are those we are going to study next. Okay, so at this stage you just remember pin number 1 and 5, they are used for offset nulling, and we have to connect the potentiometer between pin number 1 and 5 for offset null adjustment. Okay, now pin number 2 is inverting input, pin number 3 is non-inverting input, pin number 4 is negative power supply, that is minus VCC. Then pin number 6 is output, pin number 7 is plus VCC, that is positive power supply. Okay, so this is what is the pin out of IC 741. Okay, the meaning of inverting input is that when you apply signal to this terminal of operational amplifier, then it amplifies this signal, but at the same time the phase of the signal is inverted. So output is always 180-degree out of phase with the input if you apply the signal at inverting input, and therefore this terminal is called as inverting terminal. Okay, now suppose if you apply uh, voltage at non-inverting terminal, suppose we are applying voltage here, so it is also going to amplify this signal, but at this time the output voltage which is amplified by the amplifier is in phase with that of input. So there is no phase difference between input and output. So it is not inverting the signal, and therefore this input is called as a non-inverting input. Okay. So now let us move to our next slide. this slide, what it shows? It shows ICLM 324. It shows ICLM 324, and this IC is again operational amplifier IC. It has 14 pins. That is what you can observe, and there are 4 operational amplifiers within that IC. How many operational amplifiers? 4 operational amplifiers are there, and pin numbers are as shown here. Okay, so each operational amplifier has 2 inputs, one plus, another minus, and one output. Okay, so here you can observe input number 1, output number 1, inputs number 2, output number 2, then inputs number 3, output number 3, inputs number 4, output 4. Okay, so 2 pins, pin number 4 and pin number 11, they are used for applying power supply. So plus VCC must be applied to pin number 4, and minus VEE, or sometimes even you can apply ground at this point. Okay, so minus VEE or ground is to be applied to pin number 11. So this is how your LM324 operational amplifier IC is. It is quad operational amplifier. Quad means 4. 4 operational amplifiers are present in this integrated circuit. Okay. Now let us go to next important part of your operational amplifier circuit, and that is uh, block diagram of operational amplifier, internal block diagram of operational amplifier. Operational amplifier is not a simple circuit, so it is a big circuit. So we cannot study its actual circuit diagram because it is very complicated. Instead, we can study its block diagram. We are going to show various components just by representing them as a block and not an actual circuit. Okay, so such block diagram is shown here on the screen. So as you can observe, there are 4 stages in operational amplifier. The first stage is called as input stage, second stage is called as intermediate stage, third stage is level shifting stage, and fourth stage is output stage. Okay, so it is simple to remember because input stage, intermediate stage, only level shifting stage is different for you, and output stage. So these are the 4 stages or blocks which are present in operational amplifier circuit. So here you can see there are 2 inputs, 1 output, one inverting input, another non-inverting input, and single output is there. Okay. Now let us discuss each block of this operational amplifier. The first block is input stage. Okay. Now what this input stage is, basically all these 2 stages are differential amplifiers. The amplifier which amplifies the difference between the 2 signals. So input stage is differential amplifier. And the type of differential amplifier used here is dual input, means it has 2 inputs, and balanced output. Balanced output means it has 2 outputs. Okay, so 2 input, 2 output differential amplifier is your input stage. Okay, so the 2 inputs are inverting input and non-inverting input. Okay, and this particular stage it decides most of the voltage gain of operational amplifier. Okay, and as it is present at the input, it also decides the input resistance of the operational amplifier. Okay, so what you have to remember about input stage is made up of dual input, balanced output, differential amplifier. It contributes most of the voltage gain of the amplifier, operational amplifier, and it decides the input resistance of the operational amplifier. So this is what is input stage. Now coming to the intermediate stage here. So what you can observe here, it has 2 inputs and single output. Okay. So this usually again is another differential amplifier, just like first one. But the only difference between this differential amplifier and this differential amplifier is that intermediate stage differential amplifier is dual input but unbalanced output. If it is having single output, it is called as unbalanced output. So dual input unbalanced output type of differential amplifier is used in intermediate stage. Okay. So it is capable of driving the other input, other stages of the operational amplifier. So this is used for converting two inputs into two outputs into single output. This is one reason, and one more reason is that it again contributes to the voltage gain. It increases the voltage gain. Suppose if voltage gain of this particular stage is A1 and that of A2, then overall gain of both these stages will be equal to A1 into A2. A1 into A2. Suppose if the gain of amplifier A1 is 5 and that of A2 is 2, then overall gain of this both stages is 10. So it is going to amplify the input signal 10 times. Okay, so this is what is the meaning of this. Now coming to the third stage, the third stage is called as level shifting stage. Okay. Now, as I told you, these amplifiers are directly coupled amplifiers. There is no component present when connecting one stage to another stage. Okay. And due to this, what happens? As we are using DC power supply to power these circuits, the output of the amplifier will include amplified AC voltage plus the DC power supply value. So output consists of both AC and DC. Okay, so this is there, and you should not have DC component in the AC voltage. Okay, for your application. So for this reason, you have to make the DC component which is present in the output of amplifier equal to 0. So this DC component has to be made equal to 0, and this function is carried out by the level shifting stage. So what level shifting stage does, it makes the DC level equal to 0 with respect to ground at the output of operational amplifier. So level shifting stage is responsible for you can say removal of DC component from the output of the operational amplifier. Okay, now the fourth stage of operational amplifier is called as output stage. Okay, so this is complementary output stage. It increases again the magnitude of voltage and raises the current supplying capability. So that is very important. So output stage is used to increase the current driving level of the operational amplifier. You can say that it is working as a current amplifier. So this also decides the output resistance of the operational amplifier, and output resistance of the operational amplifier must be as much low as possible. Input resistance must be as much high as possible. Okay, so this is all about the output stage. Are you clear about this, students? Are you clear about this? नाहीतर मी बोलत जायची, तुम्हाला समजतंय न समजतंय मला काही कळायचं नाही. बोला कुणीतरी, समजतंय नाही समजतं, काय समजत नाही ते विचारा. तेजस,
नो मॅम, काय करायचं ते कळलंच नाही.
कुठलं काय कळलेलं नाहीये त्यातलं?
तेजस
हा,
स्टेज मॅम.
स्टेजेस मधलं कळलं नाही का? आता स्टेजेस मधलं कसं आहे, सगळ्या बेसिक गोष्टी आहे ना तुम्हाला माहिती नाहीये, बरोबर? एक मिनिट आहे, काहीतरी गडबड झाली. हा, हे शेअर करतो. हे दिसायला लागलं ना आता तुम्हाला?
येस मॅम.
हे स्टेजेस बद्दल एकदा तुम्हाला मी मराठीत सांगते म्हणजे तुमच्या लक्षात. हे जे 4 स्टेजेस आहेत ना, या ऑपरेशनल एम्प्लिफायरच्या सर्किटमध्ये काय आहे हे दाखवतात हे स्टेजेस. त्याच्या इनपुट स्टेजमध्ये काय असतो, डिफरन्शियल एम्प्लिफायर नावाचा एम्प्लिफायर असतो. डिफरन्शियल एम्प्लिफायर म्हणजे काय, असा एम्प्लिफायर जो 2 इनपुट मधला डिफरन्स, म्हणजे एका टर्मिनलला 1 व्होल्ट दिलंय, दुसऱ्याला 2 व्होल्ट दिलंय, तर 2 - 1 1 व्होल्ट हे एम्प्लिफाय होणार. म्हणजे डिफरन्स बिटवीन द इनपुट सिग्नल्स विल बी एम्प्लिफाईड. अशा प्रकारच्या एम्प्लिफायरला डिफरन्शियल एम्प्लिफायर म्हणतात. आणि असा डिफरन्शियल एम्प्लिफायरच याच्यामध्ये असतो. ओके, डिफरन्शियल एम्प्लिफायर वापरून हा ऑपरेशनल एम्प्लिफायर बिल्ड केलेला आहे. पहिल्या स्टेजमध्ये जो डिफरन्शियल एम्प्लिफायर वापरलेला आहे, तो डिफरन्शियल एम्प्लिफायर कसा आहे, ड्युअल इनपुट आणि बॅलन्स्ड आउटपुट. म्हणजे त्याचं जे इनपुट असतं ते 2 इनपुट्स असतात आणि आउटपुट सुद्धा 2 असतात त्याला. ओके, विथ रिस्पेक्ट टू ग्राउंड बघत नाही आपण आउटपुट. आउटपुटचे जे 2 टर्मिनल आहेत त्याच्यामध्ये आपण आउटपुट बघत असतो. तर अशा प्रकारचा डिफरन्शियल एम्प्लिफायर इथे प्रेझेंट असतो. आता ह्या पहिल्या स्टेजच्या एम्प्लिफायरचा उपयोग काय आहे, तर मॅक्झिमम गेन प्रोव्हाइड करणं. म्हणजे मोस्टली एम्प्लिफिकेशन जी स्टेज करते ती पहिली स्टेज आहे. ओके, आणि त्याचप्रमाणे त्याचा इनपुट रेझिस्टन्स जो आहे तो पहिल्या स्टेजवरच डिपेंड आहे. ऑपरेशनल एम्प्लिफायरचा इनपुट रेझिस्टन्स जो आहे तो पहिल्या स्टेजवर डिपेंड आहे. ओके, आता इंटरमिडिएट स्टेज म्हणजे काय असते, इंटरमिडिएट स्टेज म्हणजे अजून एक डिफरन्शियल एम्प्लिफायरची स्टेज आहे ज्याच्यामध्ये ड्युअल इनपुट म्हणजे 2 इनपुट असतात त्याला आणि आउटपुट मात्र एकच असतं. म्हणजे 2 ऍक्च्युअली जे आउटपुट असतात त्यातलं एकच टर्मिनल विथ रिस्पेक्ट टू ग्राउंड जर जोडलं तर त्याला अनबॅलन्स्ड आउटपुट असं म्हटलं जातं. आणि अशा प्रकारचा डिफरन्शियल एम्प्लिफायर हा इंटरमिडिएट स्टेजमध्ये प्रेझेंट असतो. बेसिकली ह्या स्टेजचा उपयोग काय आहे, तर ते डबल आउटपुट जे आहे ते सिंगल आउटपुट मध्ये कन्व्हर्ट करणे हा त्याचा उपयोग आहे आणि ऍडिशनल गेन प्रोव्हाइड करणे हा त्याचा उपयोग आहे. आता तिसरी स्टेज आहे ती लेवल शिफ्टिंग स्टेज. लेवल शिफ्ट म्हणजे डीसी लेवल ऍडजस्ट करणं, एखाद्या एसी व्होल्टेज मधलं डीसी लेवल ऍडजस्ट करणं, त्याला लेवल शिफ्टिंग असं इलेक्ट्रॉनिक्स मध्ये नाव आहे. आता इथे जे आपण एम्प्लिफायर्स यूज केले पहिल्या स्टेजमध्ये दुसऱ्या स्टेजमध्ये, ते कसे एम्प्लिफायर आहेत, डायरेक्टली कपल्ड आहेत. म्हणजे डायरेक्टली एक स्टेज दुसऱ्या स्टेजला नुसत्या सिंपल वायरने कनेक्ट केलेली आहे. असं केलं तर काय होतं की जो एसी आहे ना त्याच्यामध्ये पॉवर सप्लायचा डीसी पण येतो. ओके, आणि तो पॉवर सप्लायचा डीसी जो आहे तो एलिमिनेट करणं गरजेचं असतं. आणि तो एलिमिनेट करायला जे सर्किट वापरलं जातं त्याचं नाव आहे लेवल शिफ्टिंग स्टेज. ते काय करतं की आता इंटरमिडिएट स्टेजच्या आउटपुटला जे एसी प्लस डीसी आलं त्यातली डीसी लेवल ते 0 करतं. म्हणजे आता तुम्हाला लेवल शिफ्टिंगच्या स्टेजला फक्त एसीच मिळणार, त्यात डीसी असणार नाही. ओके, आता मग आउटपुट स्टेज जी असते ती बेसिकली कॉम्पोनंट इतर स्टेजेस ड्राईव्ह करण्यासाठी वापरली जाते. म्हणजे करंट जो आहे ड्रायव्हिंग करंट तो या स्टेजवर डिपेंड असतो. म्हणजे आउटपुट स्टेज हा करंट एम्प्लिफायर म्हणून वर्क होतो आणि करंट कपॅबिलिटी जी आहे ऑपरेशनल एम्प्लिफायरची ती आउटपुट स्टेज वाढवतो. आणि ऑपरेशनल एम्प्लिफायरचा आउटपुट रेझिस्टन्स या आउटपुट स्टेजवरती अवलंबून आहे. इनपुट रेझिस्टन्स जसा इनपुट स्टेजवर आहे तसा आउटपुट रेझिस्टन्स हा आउटपुट स्टेजवर अवलंबून आहे. ओके, आणि कसं असलं पाहिजे, इनपुट रेझिस्टन्स खूप हाय असला पाहिजे नेहमी आणि आउटपुट रेझिस्टन्स खूप छोटा असला पाहिजे, लो असला पाहिजे. ओके, आता लक्षात आलं का तेजस या ब्लॉक्स बद्दल?
येस मॅम.
हा, आता कसं आहे, हळूहळू जरा इंग्लिशची सवय करून घ्या. मी मराठीत सांगायला मला प्रॉब्लेम काही नाहीये, पण जेव्हा तुम्ही आता समजा एक मल्टिपल चॉईस आहे, पण जेव्हा तुम्ही डिस्क्रिप्टिव्ह आन्सर्स लिहिणार तेव्हा ते इंग्लिशमध्ये लिहिणे अपेक्षित आहेत ना तुम्हाला. आणि मग त्यावेळेस तुमची व्होकॅब्युलरी जी आहे ती कमी पडता कामा नये. तुम्हाला एक्सप्रेस करता आलं पाहिजे, कारण मुलांना येतं समजतं. मला माहिती आहे आपल्या मुलांचा हा प्रॉब्लेम आहे की ते पुन्हा इंग्लिशमध्ये आन्सर लिहिताना त्यांना अडचण येते. तर ती येऊ नये हा माझा उद्देश असतो. त्यामुळे मी सिंपल इंग्लिशमध्ये घेत असते लेक्चर, कारण इंग्लिश येणं तुम्हाला आवश्यक आहे पुढे करिअरच्या दृष्टीने सुद्धा. ओके, आता पुढे इथे काय दिसतंय
येस मॅम.
स्क्रीनवरती, वाचा बरं. opamp parameters and idealized characteristics. opamp ला काही पॅरामीटर्स असतात. ओके, ते पॅरामीटर किंवा त्याचे स्पेसिफिकेशन्स म्हणा, थोडक्यात ऑपरेशनल एम्प्लिफायरचे स्पेसिफिकेशन्स आहेत ते पॅरामीटर्स. म्हणजे त्या पॅरामीटर्सची डेफिनेशन शिकणं आपल्याला आवश्यक आहे आणि त्याची आयडियल व्हॅल्यू किती आहे हे माहीत असणं आपल्याला आवश्यक आहे. आता इथे पहिला जो पॅरामीटर आहे त्याचं नाव काय आहे सांगा बरं जरा मला.
Open loop gain.
करेक्ट, ओपन लूप गेन. आता हा जो ओपन लूप गेन आहे त्याची आयडियल व्हॅल्यू इन्फिनिटी असते. इन्फिनिटी माहिती आहे ना तुम्हाला? काय
Yes, ma'am.
इन्फिनिटीचा अर्थ? काय अर्थ होतो इन्फिनिटीचा? खूप मोठी व्हॅल्यू, अमर्याद. ओके, अमर्याद
Yes, ma'am.
असा त्याचा अर्थ की त्याला लिमिट नाही. इट इज मॅक्सिमम पॉसिबल व्हॅल्यू. सो आयडियल व्हॅल्यू ऑफ ओपन लूप गेन इज इन्फिनिटी. हे लक्षात ठेवा, परीक्षेच्या दृष्टीने महत्वाचं आहे. ओके, सो व्हॉट इज द मेन फंक्शन ऑफ ऑपरेशनल एम्प्लिफायर? टू एम्प्लिफाय द सिग्नल. ओके, सो व्हॉट इज ओपन लूप? ओपन लूपचा अर्थ काय आहे? जेव्हा आउटपुट हा इनपुटला कनेक्टेड नसतो, म्हणजे जेव्हा फीडबॅक नसतो, जेव्हा फीडबॅक नाहीये, त्या कॉन्फिगरेशनला ओपन लूप असं म्हणतात. आणि जेव्हा तुमचा ऑपरेशनल एम्प्लिफायर ओपन लूप असतो, सो व्हेन देयर इज नो प्रेझेन्स ऑफ फीडबॅक, at that time what is the gain of operational amplifier? So that gain is nothing but open loop gain. And how do we calculate the gain? Gain is nothing but ratio of output voltage to input voltage. So voltage gain, it is called as voltage gain. Okay, so open loop voltage gain is ratio of output voltage to input voltage in open loop configuration of the operational amplifier, and its ideal value is equal to infinity. Okay, now let us define the next parameter, which is nothing but your input impedance. Okay, so input impedance or input resistance, both things are same. So if you see here, the ideal value of the input impedance is equal to infinity again. Okay, so what is input impedance? It is defined as the ratio of input voltage to input current. Okay, so it is assumed to be infinity. So V upon I. So when it will become infinity? When I is equal to 0. V upon 0 is equal to infinity. That means what is meaning of this? Meaning of this is that current entering into the terminal of operational amplifier is always considered to be 0, ideally to be equal to 0. In practice, it is not, but ideal model is considered for simplified calculation. Okay, so next we are going to see how it simplifies the calculation.